right, we're going to get started now. Our first presentation is Keeping Synergy Modern. Marty has been with Synergex since 2007, working on products like Workbench and Synergy DBL integration for Visual Studio. You may know him from past conferences where he's presented on any number of product related topics. In his current role, he's working across teams to improve processes and drive innovations that help our customers modernize their systems. Now, Marty is going to share how we approach modifications to our language and tools, and he'll take a deeper dive into some of our new features.
Welcome to Keeping Synergy Modern. Or really, what are we up to with continuing to keep the language and tools modernized and meeting your needs? At the highest level, we want to enable your applications to continue to execute and bring value to your organizations well into the future. In order to achieve that, we need to make investments into the language and tools that support that eventual goal. Forming the basis of our focus is longevity and stability. We want to target changes that future proof the Synergy language in a way that will keep your applications viable. That may be necessary changes to keep the tools working on new versions of operating systems, changes to support the newest encryption or data transport standards, or even the maintenance of that language with new versions of .NET or implementing changes to enable migrations to new or long-lasting platforms. Whatever it takes to adapt to market and business needs. Above that, we have performance. Whether runtime performance, ISAM performance, or compiler performance, we want to make sure that the tools are fast enough to meet your needs. Then, of course, also feeds into longevity. If the tools are not fast enough, that would be a serious detriment to the longevity of your application. And finally, quality of life. Implementing features and functionality to make the tools easier to use and fit your developer workflows. Things like new syntaxes to better represent things, or reduce code complexity, or enhancement to how tools operate in DevOps spaces. These also feed back into longevity. Let's explore a few of the recent compiler changes to take a look at how this fits together. For the first problem, customers are experiencing growing compile times with Synergy.net as assembly counts continue to climb, which is exacerbated by the adoption of .NET 8 and NuGet. Furthermore, the metadata load APIs where we spend some of this handling have been deprecated by Microsoft. This is a serious problem to the longevity of the tools. Deprecated APIs show a clear indication of a problem that needs to be resolved to ensure that these tools will be able to operate for the next couple of decades. Combined with the performance problem, there was room for a bigger impact. How we solved it was with new loader tooling called ASM to DBP. This utility uses the latest assembly load APIs to process the assembly metadata in one pass and store it in our own metadata format. This lets the compiler tooling have lightning fast load times of the necessary information that is stored in a controlled format and decouples the actual .NET metadata processing. We still have to do that processing of the .NET assemblies, which still takes time, but now we only have to do it once on your machine per version of the assembly. We build our own metadata cache to reduce load times for future builds. Not only did this improve longevity through removing deprecated APIs and improve performance, but it also made design decisions to reduce friction of any future metadata load changes. Let's look at another compiler change. The problem is that some code patterns are difficult to cross-compile between traditional and .NET. I know this is something that Synergy consultants have probably had to deal with. Synergy.net is far more strict about a number of language features than traditional Synergy. When we first introduced Synergy.net, that was actually a design goal with the intention of improving the quality of your code. As the product has matured a little bit, we have looked for areas to relax those rules when possible to enable more migration paths and cross-compiled code. Some things cannot be relaxed away. For something like the use of #ref for value types in .NET, we saw that it was a real blocker for customer source bases and had to work through design challenges to allow synergy value types to pass by ref. Maybe less design, but still an irritant, was the inability to use the deadder type with default parameters in .NET. When you're trying to migrate code, the last thing that you want to be doing is troubleshooting why the language works fine for your I8, but not for deadder. And while looking into href, we found inconsistencies in different data type handling. Given the opportunity, we resolved those to reduce friction for the next developer that tries to use href on an array of structure. And we can't really talk about keeping Synergy modern without discussing .NET. Since .NET is an ever-evolving runtime and toolset, so too must the language continue to. Oftentimes, we are able to support new .NET features completely for free. So whenever the .NET platform adds new major libraries to support functionality or extend functionality in new ways, your applications are able to take advantage of it on day one. For example, most .NET libraries are making use of dependency injection for supplying and loading interface implementations. That's a major piece of tech that Synergy did not have to implement at all. It just works out of the box. Typically, anything that generates the same IL or intermediate language is going to work without implementation or with very minor implementation. However, some .NET features are a lot less free. When Microsoft and C# create whole new IL patterns or type patterns or constructs, they will not work with the language immediately. Like if they add a new kind of generic constraint or handling of structures or build some whole new creation on top of attributes that enables new functionality, we have considerations to make on how to support those things in the language. Sometimes we only do the minimum of being able to interface with the new feature, like structures that implement interfaces, which we can only consume, or we may go into full support for the feature, including new syntax and handling in the language, like default method implementation on interfaces. When the team is evaluating these features, it is with the same longevity, performance, and quality of life concerns that we already discussed. In recent versions of C# and .NET, there have been a number of features that are not immediately free. So the team is currently working on supporting some of these things to ensure that you will be able to make use of the next wave of libraries and features from other developers. As I mentioned before, Synergy only does the basics for consuming structures that implement interfaces. In addition to that feature, there is now support in .NET for implementing interfaces on ref structures, which are their own variety of structures that live on the stack instead of the managed heap. We aren't looking to support interface implementation ourselves, but we do think it's valuable for you to be able to consume these from other libraries and APIs. So we are working on being able to recognize ref structures and structures that implement interfaces and handle all the logic for assignment and implicit conversion of those things to their constituent interfaces. Another new feature in .NET that we have already had in Synergy for a while, but not exactly in this format, is something called inline arrays. These are specifically attributes on a special type of buffer structure that allows declaration of contiguous size up front and allow various implementations for assignment to like span and read-only span. They can also be used as collections for iteration in things like for each. Just in case you are handed one of these things from an external library, our compiler needs to know how to deal with it. And if you're familiar with var args, then you already know what the param syntax is for. .NET has its own concept for how to handle var args, and that is to apply a params attribute to an array argument that will accept all of the trailing parameters. While new in .NET is support for that on collections instead of just arrays, so they can be types like list, enumerable, span, or anything like that. While we don't have the same syntax, you need to be able to call methods from libraries that have these things declared. So we're implementing some support for this .NET specific var args. And if this last one looks like a mouthful, that's because it is. They've added an attribute that allows a library author to define overload priorities on their methods. So if you call a method with one signature, A less specific method with a matching signature could be signaled as preferred. This is ostensibly for supporting long-lived libraries that want to push new functionality forward, but feels a little bit like a kludge. Nevertheless, we need to understand it and ensure that when you call one of these overloads, you get the right one. And those were just the minimal support features. We do have some other features in the pipe that are more complete implementations but have a longer runway. Like support for additional partial members. The addition of partial classes is a big win for environments with either massive classes with lots of implemented interfaces, or more specifically in use cases where you use tools like CodeGen to create a lot of source code, but need to be able to implement parts of it yourself without worrying about your changes getting wiped out. We use these features a lot internally, and .NET has added a variety of additional partial members like properties, indexers, and events. We've already had support for methods across partial classes, and are looking at implementation of these new members as well. This is likely a feature to make its way to traditional to keep the language in sync. .NET has also added support for declaring new kinds of extension members. If you haven't used extension methods before, the concept is to let you write your own method or things as though it were a member of a class without it actually being part of the class. This allows for far more seamless use of extended functionality, as you can call or access the extension directly from an instance of the type. A really popular example would be system.link, which adds a number of extension methods to collections like where and order by. New versions of .NET have support for extension properties and extension operators on top of the method support. We'll be working out a syntax to allow you to declare your own extension properties in Synergy, but operators will most likely stay as something to be loaded from other libraries. And beyond these are a few minor quality of life enhancements as well, like being able to use null conditional operators on the left side of an assignment expression, or passing an unbound generic type to hat name of to get the names of your generic types like list if you want. We're expecting the first batch of enhancements to ship around the same time as .NET 10 this fall, with more to follow in subsequent SDI updates. So stay tuned to the blog for more .NET feature availability. So now that you have a taste of how we decide to tackle problem areas, I want to talk about another big problem space that has brought in a ton of feedback and a major theme for this panel: unlocking DevOps. It's not that DevOps workflows are totally blocked in your organization. Far from it, actually. Many of you have full processes for your Synergy code, whether built yourselves or have had it built by our professional services team. You do your development on Windows in Visual Studio. You get all of the rich editor functionality and the deterministic builds, and everything is great. You push those changes to source control, and your continuous integration on Windows pulls those changes, builds the Visual Studio projects targeting your final platform. Maybe you run tests, and you do something with the artifacts. Then finally, you deploy on the target platform, whether that's Windows or Linux. But what we've heard loud and clear is that you would prefer a slightly different workflow. So here's the new vision. Much as before, you do your development on Windows in Visual Studio. We still think that's the best place for you to be developing. But after you push those changes to source control, your CI on Windows, Linux, or both can pull those changes and do builds. Furthermore, they do builds with the Visual Studio projects regardless of platform. Then, finally, you deploy on the target platform, whether that's Windows or Linux. In order to make this happen, we need to make some changes to traditional Synergy to support it. If those Visual Studio projects are going to work, all of the tooling needs to be readily available and deployed the right way. Rather than develop a whole new product install for your Linux systems, the path forward is a Microsoft technology called SDK projects. This NuGet-centric tooling has us distribute all of the build support in a NuGet form that a little more directly integrates than a regular NuGet package. By packaging native platform tools, we can enable one consistent mechanism for doing your project builds, as long as you have your Synergy DE and licensing present. The end goal here is to enable the easiest build experience. Pull sources and run .NET Build. This will automatically pull the right version of our SDK package, load all of our targets and tools, and proceed with building your solution using the designated SDK. Even better, you can specify the SDK version once at the top level of your solution and update it for all of your projects at the same time when you need to. We also think that it's about time that you should be able to run your traditional Synergy unit tests, which have so far been platform locked to Windows. So just like the build tools, we also have the unit testing tools bundled up into an SDK package to enable the use of .NET Test. Just like the project build, the test tool can read our test, load the test execution right from the SDK package, and load all necessary parts of the framework directly. It can read your test library, find the test to execute, and get you results. This whole flow works on both Windows and Linux, so you can have solutions be truly portable. Well, what about everything else? Building your traditional Synergy projects would be pretty incomplete without the inclusion of repository projects, script projects, and all the other tools, right? The only real answer to that question is that everything else also has gone cross-platform. In addition to the traditional unit test framework, we have ported the SDI era script compiler, which supports both Windows and Unix toolkit window libraries. It is now built as a cross-platform .NET 8 application and produces consistent results for your build. We've also given RPS-UTIL the same treatment. So whether you run on Windows or Linux, you have the same tools building your repository and toolkit window libraries. Same tools, same build reliability and functionality, but working where you need it to work. And that also includes Synergy.net, of course. Thanks to the efforts from the compiler team, we have ported the Synergy.net compiler to also run natively on Linux. It just makes sense. With .NET 8 so portable between operating systems, having the Synergy compiler only able to build .NET on Windows feels really incomplete. No longer will Linux be traditional Synergy only for build. You can also build your .NET 8 plus Synergy.net project locally on that operating system and boost the potential of your continuous integration configuration. It's worth noting that this realistically does not support .NET Framework, as the supporting libraries are mostly not present on Linux. We still require the use of Visual Studio projects in order to build Synergy.net on Linux. The whole system is also driven by that same SDK project technology and requires a fully defined project to build correctly. And naturally, this also brings along all the supporting tools. The new ASM to DBP that we discussed earlier is also ported for handling our metadata load features, and DBLNet to XML is also present for generating those XML doc files. Adopting the new SDK projects can be done incrementally or all at once. The total change required to a SynProj file is very minimal to go from the old targets to the new SDK, and the projects are fully compatible to use and reference alongside your existing projects. We see two main approaches for getting to SDK projects: either build new projects using the new SDK project templates, or do a simple and straightforward conversion. Converting a project is as easy as add the new SDK attribute to the project tag, remove the old package reference or target import, and build. You're already done. Best of all, this functionality works without even installing a new version of SDI. Since all of the tooling is self-contained in the SDK, switching to the new target is all that you need to do. The change per project is designed to be as minimal as possible. Adding the new SDK tag really is as simple as adding a single attribute to your project declaration. I would also recommend that you keep the default targets just to control which targets get run by default, and consider adding restore to it, but this diff shows the actual amount of change required to convert one of our internal projects over to the new SDK style. Swap in the SDK attribute, remove the target import. All done. We'll go more into these changes very shortly. The final piece of the puzzle for SDK projects is the global.json file. You only need to have one of these at the solution level to get the benefit of controlling your SDK versions in one place. The global.json file is a very simple format for declaring the list of project SDKs and which version you want to target. When builds or NuGet restore happens, MS-build or .NET build will look for a matching file name at the project level, then solution scope to determine which SDK versions to load. From there, the right version of the package is pulled down automatically and our build targets get loaded. Our 4 new SDKs are Synergy.net, Synergy.traditional, Synergy.traditional.unittest, and Synergy.repository. When we rev these packages, we'll make sure to include the version number in our blog and communications so you can update directly, or you can always find out what the latest version is on NuGet. This file is not currently managed by SDI, but we're looking into ways to make this part of the experience even easier.
Okay, I have a solution with a mixed bag of project types. It's been concentrated down to demo size, but I do have a little bit of everything. There's a toolkit window library, a repository, a .NET library, a traditional unit test project, a traditional ELB, and of course, a traditional multi-mainline. I suspect most of you have a solution with some combination of these things, and I wanted to have as many as possible to demo the functionality. The general idea is that it should only take us a few seconds to convert each of these projects. I'll quickly run through all of them, and then we can have a look at the end results. This is a real solution of content. If I build this thing, and then we look in the test explorer, actually, it's going to take a moment because I have actually quite a number of main lines. If we get this guy all the way built, you should be able to see my 250 or so tests. Give it a moment. Thank you, antivirus. Okay. Now Test Explorer is running and 250 tests. Great. We can also run these things. They are real. Perfect. 250 passed. By the end of this, we should be able to build and run all of this on Linux too. I actually have a Linux WSL box that is running here in the exact same code location. And if I try to build this, it fails catastrophically. It doesn't know how to build them at all. So how do we do this? The very first thing that we're going to do is create a file in my solution called global.json. Global.json is the mechanism that Microsoft has given us to control which version of SDKs get targeted in a solution. So if I open up File Explorer, let's do that. Open folder in File Explorer, and then add a new text file called global.json. .json. Yes. And then I should be able to open that in Visual Studio, and we have an empty JSON file. There's not much that we have to do with this thing. Do have to add a little bit of scaffolding because it is JSON, and then we're going to create the MS Build SDKs item. And then inside of this, we're just going to create our various SDKs. So we've got synergy.traditional, and we've got synergy.traditional.unittest, synergy.net, synergy.repository, and synergy.script. You may or may not need all of these, but since I've done one of everything, I have to have it all. And then, of course, we have to give these the required versions. So for me, it's going to be 1.0.0.1-PR4. I'm running on a pre-release version. These could still generally get some revision in terms of the version number. They don't really line up with any of our existing version formats for, the Synergy DE products or SDI. We're still figuring out where that's going to land, so we thought we'd start somewhere safe increment from there. And then no matter what direction we go, you'll always be able to target a newer version. So this is it. This is a fully built global.json file. I'm going to go ahead and save that. You can actually get away without using a global.json if you really wanted to. There is a declaration format that allows you to put the SDK version inline in your files, but declaring it all in one place is a good habit to get into. Okay, with all the version numbers defined on each of our SDKs, we can start the conversion process. Let's quickly unload all of our projects. There we go. And then one by one, we can make the update. For each of them, the goal is pretty simple. Declare the SDK that we want to target, clean up the old target mechanism, and that's it. It's actually easy enough that you could probably find and replace these things with good success, but I'm going to do it the hardest way possible to show that it's totally feasible to do within this window. Okay, so for the script project, we're going to get rid of the tools version tag, put in an SDK tag, and say synergy.script. That adds the SDK tag or the attribute, and we're also going to remove the old import. So it does a import on synergex.script. Easy. Come over to repository and do the same thing. So SDK equals synergy.repository. And then repository could come in a couple of different formats. So this one has an import on an old style NuGet package. We're just going to delete that whole block. Perfect. This .NET project is already targeting .NET 8, so it has an SDK tag. We're just going to switch this over to synergy.net. And there is no other fix-up to do because it already gets everything from an SDK. Coming over to the unit test project, we're going to once again drop the tools version SDK equals synergy.traditional.unit test. Perfect. And we remove the import. This one's my traditional ELB. So instead of traditional.unit test, I'm going to target synergy.traditional. And remove the target. And in my multi-main line, it's the same thing. It's just a traditional SDK. And we come down and remove the target. Easy enough changes, right? Right. So that was 6 projects done in just a few minutes. In theory, I should just be able to reload them. I'm going to go ahead and close all these, and then I'm going to reload them, but I'm also going to be kind to Visual Studio. I know it gets a little cranky when you change out all of the project targets out from everything, so I'm going to close VS. And I'm going to reopen back into my same solution. This gives Visual Studio a chance to actually read in all of the updated packages and understand that the targets have changed. Okay. Let's make sure it all builds. Perfect. And we have all of our tests still running. This is good. And coming back over to Linux, it really should be as easy as .NET build. So we're going to do a .NET build. All of our code already has the right if-defs and everything to support being on Linux. The .NET build does the restore and everything automatically, and everything is built. You can see that the multi-main lines still take some time. And just to make sure all of it is actually working all the way through, let's do a .NET test as well. The testing tool loads dynamically from the package, reads in the tests from our corelib.tests ELB, and executes all of them on this previously inaccessible platform. There we go. 250 tests passed.
If it seems like that process is a little too easy, that's because it's designed to be. We've been able to deliver pre-release versions of this functionality to a few select customers, and adoption was fast and straightforward, without the need of a new version of SDI and no support for project templates even available at that time. The feedback has been incredible, especially around build performance. The build performance on the tools running on Linux is up to 8 times faster in many cases than the comparable builds running on Windows. That's a full solution of build running 800% faster. The difference is so significant that we have already begun evaluating and removing blockers to allow more cross-targeting the other direction, allowing your Linux build nodes to target Windows. So stay tuned for even more enhancements in this space. So what do you say? Do these DevOps enhancements deliver? I think we've checked all 3 areas with this set of changes. Who has the first question?
All right, Marty, you've been busy. Let's take a look and see if we've got any questions. Thanks,
I
everybody.
did want to take a moment to note, while these things are pretty much good to go and those pre-release packages are out there and usable, we are still working on our final ship of this, hopefully available very soon. There will also be an SDI build coming with it that has all of the template support to make adoption easier when you're doing brand new projects.
All right, folks, don't be shy. Please ask some questions, but I have a few while we wait. Marty, how do you plan to measure success for these modernization initiatives? Developer adoption, performance gains, or ecosystem contributions, or all of them?
I think it's definitely a mix of developer adoption and performance gain. Performance gain is a nice metric for us to show that we've made meaningful improvements with changes. But those changes aren't really useful unless we've got developers actually using it. So get on newer versions of Synergy, on newer versions of SDI, use all of our new features and functionality. That's how we'll know that we've actually had success with these changes.
And how do you ensure the stability of these modernization features?
That is a great question. So we actually run all of our compiler enhancements at the very least and Visual Studio enhancements through a battery of tests that are designed on customer source bases. So we have an in-house test suite that is actually your code and not just our sample code where we run all the validation against. So when we introduce a new warning and it has an impact on customer source, we see that immediately. And usually we will reach out and let people know if we think it's going to be a noticeable difference. So having that helps us a lot when we're designing actual new features and areas where we think we're going to make big performance changes.
And my last question, it's great to see all of the modernization changes, but I still have to deploy to my customers on 11.1.1i. How is this stuff useful to me?
Well, Rachel, you should definitely get your customers upgraded from 11.1.1i.
I agree. That's not in support anymore.
It's not supported, but
no,
we still support you. The big thing is our tools still support back targeting. So the compiler tools in Synergy.net and traditional Synergy can still target older runtimes. So even though you're using all of the newest tooling, you can still target your 11.1.1i system, deploy your build programs to that environment and not have any problems.